Yes, welcome to the last part of what if analysis. We shall look at another tool, which is the solver. The solver helps us to analyze a complex situation. For example, for our case here, we have this distribution problem where we have the costs of transporting different items to different destinations. That is Mbale, Masindi, Gulu, Masaka. From these manufacturing plants, Kampala, Entebbe, Luwero. So we have the costs here, but we also have the constraints, that is the demand constraints. For example, Mbale, they are demanding 1,100, Masindi 400, 750, Gulu and Masaka 750. But when you look at our plants, Kampala can only produce 1,200, Entebbe 1,000, and Luwero 800. So we shall use another tool called the solver to be able to analyze that situation. Now, when you go to the data menu, if you have not used solver before, you will not see it displayed somewhere around here like it is with this particular computer I'm using. So therefore, how do you bring it over here? So you go to the file menu, then you click on options, then you select add-ins right here. So you click on add-ins, then after clicking on add-ins, you will see solver add-in right here. So you click on it, it will be highlighted blue, then you click on this button go. It will display very many other tools, but the one you want to use is the solver. So you check it, then you hit the OK button. So it will take some few seconds to load that particular plugin that will support us to perform this analysis. So when you go back to the data menu, you'll be able to see the solver right here. So before we get into using this particular solver, we have to organize this work such that it is ready for solver. So at the moment, we have the unit cost for transporting each item to a given destination. For example, from Mbale, from Kampala to Mbale, it will cost 35,000, but you don't know the quantity that will be picked from Kampala to Mbale. So that will be our task, and the solver will help us do that. So to simplify this, we shall copy this particular table right here. So we shall copy and paste it somewhere below, right there. Then we shall merge some cells, and we shall be able to give it a title. For example, optimal distribution. So after giving this particular title, we shall delete this content because we don't need it. So we shall just highlight and delete the content. Then we need to compute the totals right here, meaning that we want to obtain the total supplied, for example, to Mbale right here. So we put the equal sign, then we use the sum function. So we shall add up the total right here from here up to that point, press the enter key, and copy the formula across up to this point. Now, for some computers, depending on the configuration, it may display the dashes or it may display the zeros. For my case, displaying the dash still it has no problem. It means that is a null cell. So we do the same to what has been transported from where. So we shall have this total here as well, implying that we want to know how many units are moving from Kampala to these various destinations. So we shall put the equal sign, then we sum those values starting from this point up to that point. So we press the enter key and copy this formula down. Okay, so now that we have done this, we also need what we call the objective cell, meaning according to what we have on our guide here, our aim is to obtain the minimum cost of distributing these items to those different locations. So therefore, we need an objective cell right there, or our target, which is to minimize the cost. So how do we do that? Like I said, this is like a matrix. For this case, like 4x4 matrix. So we have to get the unit cost of transportation times the quantity that the machine will obtain right here. So how do we do that? We use the sum product formula, rather function. So you type sum product. So before I even put the bracket, you can see it returns the sum of the products of corresponding ranges or arrays. So we click on this function. So our first array of values, or the series of values, are our unit costs of distributing each item to those different destinations, as you can see from the syntax here. So we put the comma. Then the second array will contain our quantities, which we are not yet sure of. The machine will determine for us. So we highlight these empty cells. That is the array 2. The array 1 were those unit costs that we have on the first table. Then the array 2 are these empty cells that will contain our quantities. So you close the bracket and press the enter key. Okay. So just to sample what this means, when you look at this, if you have to transport a given number of units, for example, to Mbale from Kampala, we are charged 35,000. So if I type, for example, 10 here, 10 units, and I press the enter key, it will just get the 10 units times 35. That's why we're having 350,000 here. So that was just to show you the sample. The machine will determine this for us. Therefore, we shall backspace this particular figure or delete it. Then we perform the computations. So now it is time to use the solver to be able to obtain these values. So click on this particular objective cell where you computed the minimum cost. Then you go to data, then you click on solver. This dialog box will appear referencing to the objective cell, which is this. That's where our minimum cost will be displayed. But what do we want to do? Set the objective cell, which is this, to maximum. No, we want to set it to a minimum value. So set the objective cell, which is this cell, to a minimum value by changing variable cells. So what will be changing here? Okay, our unit costs will remain the same. What will be changing here will be our quantities. We want the computer to manipulate these quantities. So what do? We have this button right here by changing variable cells. So you click on this button, then you come and highlight these cells where our quantities will be displayed. So you highlight these empty cells and press the enter key. Then these cells will be changed subject to constraints. What do we mean here? Mbale needs 1,100, that is a demand constraint. Masindi needs 400, etc. But you find that Kampala can only supply 1,200, and Entebbe can supply only 100 units. Let's check on this. It's supposed to be 1,000. So we can go and make that adjustment. So Entebbe can only supply 1,000. So those are the constraints that we have. Okay, that we are setting that to a minimum value by changing these cells subject to these constraints. So we are supposed to add these constraints. We are setting the objective cell to a minimum value by changing these varying cells subject to some constraints that we have here. Okay, So you click on the add button to add those constraints. So you click add, this dialog box will appear. We have the cell reference and the constraint. So we are starting with the demand constraint. Okay, so this means that the total supply to Mbale should be equals to what Mbale demands, which is right here. Then you click add. Total supply to Masindi should be equals to what Masindi demands, which is right here. So you click add. Total supply to Gulu should be equals to what Gulu demands. Then we add. Total supplied to Masaka should be equals to what is demanded in Masaka. So we are now done with the demand constraints. We can now start on the supply constraints. You click add and you say that total supplied from Kampala should be equals to what Kampala can produce. You add total supplied from Entebbe should be equals to what Entebbe can produce. We add total supplied from Luero should be equals to what we can produce in Luero. So now we are remaining with only one constraint, which demands that these values that will appear here should be integers. So we click add and we come and highlight the reference cell as this, then should be integer. So you select int right here, then you hit the OK button. So those constraints will be displayed here. At any time you can change them in case you feel like you're not contented with one of them. So what will be our solving method? We shall pick simplex linear programming method. So you click on it, then you hit the solve button. Okay, so it will return for you this particular message: solver found a solution, all constraints and optimality conditions are satisfied. So in case you find some error message, for example with an exclamation mark, that simply means that perhaps you confuse the process of assigning those constraints. So you can try to redo them in case that happens. But the ideal is that you must find this particular message which reads solver found a solution. So we can generate the report as well. So you click on answer, then you check on outline reports, then you hit the OK button. So the report worksheet will be generated automatically and will have these values here. Okay, so in circumstances where there are variations, the slack will mean the difference, which will either be negative or positive value, meaning either you have supplied excess or you have supplied less. So this report will be generated automatically when you complete that process. So this is our minimum cost of distributing these items, that is 84 million. Thanks for watching. Please make sure to do practice such that you get more familiar with the solver. See you in the next module.